the last question here, C, is definitely a pre-AP question. So first step, get the absolute values alone. They are. So we would say that we're okay if the inside is x squared minus 9. We're okay if it equals the original, x squared minus 9, or it equals the negated original, which in this case is negative x squared and positive 9. Now, this is, like I said, a pre-AP question, and the reason is going to become very clear here. X squared minus 9 equals x squared minus 9. Okay, I want to get the x squareds alone, so I'll bring this over to the other side. I'll minus it. And at the same time, I'll add 9 to get rid of that over to here. So on the left, I have x squared minus x squared, which is 0. Those are gone. Those are gone. And negative 9 plus 9, which is 0. And my x's are completely eliminated. There's nothing there. So sometimes you'll cancel things out. Well, most times you'll cancel things out. You'll get x equals 7 or x equals 70 or 12. That's your answer. Sometimes you'll get things like 0 equals 5. And you're like, well, that doesn't make sense. In that case, there's no answer. But this time, the x got eliminated and we got a true statement. 0 equals 5 is a false statement. The x's are eliminated, but there's a false statement, so we just reject it. But what does it mean when it says 0 equals 0? So we're going to come back to that. Let's do the right side here. Now I'm going to get the x squareds onto the, I'll move this x squared over onto this side. And at the same time, I'll add the 9 over to this side. So x squared plus x squared is 2x squared, and 9 plus 9 is 18. Then I can divide by 2. So I have x squared is equal to 9. Square root both sides. And I have x is equal to 3. Now, whenever you square root a square, and when you solve for an x and use square root to get rid of the square, you end up getting plus or minus 3. Okay, so I've got x equals 3. I have x equals negative 3 that I need to check. And I get the 0 equals 0. And so what we're going to do instead of this is I want you to look at the graph x squared minus 9. So I'm going to say, let's take a look at this graph and let's take a look at that graph because we did graphing last day. So let's take a look at x squared minus 9. Now, what does that graph look like? Well, this is one of those tricky ones where it's not in vertex form, but we can write x with as many zeros as we want. We can add plus 0, plus 0, plus 0, plus 0. But if we just add 1 plus 0, just a single plus 0, then it looks like it's in vertex form already. Another way we had done that in class is to write x squared plus 0x minus 9. And then when you complete the square, you put an x here. You cut 0 in half. 0 cut in half is 0, so you put it there. And then you have 0 squared, which is 0. So and times by the number in front. There's nothing in front. So 0 squared, you're at 0. You need to get to negative 9, so you're going to minus 9. Either way, you're going to get the exact same thing. X plus 0 squared minus 9. So whenever you're missing the middle term, you can put a 0x and complete the square. I just jumped right to this. Now, what does this look like on a graph? Well, I've got a vertex of 0, comma, negative 9. So 2, 3, 4, 5, 6, 7, 8, 9. 0, comma, negative 9. And then there's a 1 out in front, so you go over 1, up 1, over 1, up 1, 2, 3, 1, 2, 3, and then over 1, up 1, 2, 3, 4, 5, over 1, up 1, 2, 3, 4, 5. So you get this graph. And so we did that a lot I think the last chapter. And that was this, yellow, the left side that I graphed. Now I want to graph the right side, the absolute value of that. So first I'm going to write it in vertex form, x plus 0 squared minus 9. By the way, I'm just going to highlight this in yellow because that's what this was the very first drawing I did. And now we're looking at the green drawing. And this is in absolute values now. Now that we know that, you could look at the vertex. I mean, it's the exact same equation over here. So the vertex, it would be 0, comma, negative 9. So I'll try to do this in gray. So 0, comma, negative 9. And then you would do the graph over 1 up 1, over 1 up 3, over 1 up 5. It would look exactly the same as this. But then there's absolute values around it. And that meant that our drawing had to be all the way up here. It had to stay positive, always positive. So anything that's down below had to get flipped up. So this is 9. We went 9 down. So instead I'll go, 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 up. And then this one was 8 down. So I'll go 8 here. And then this one I think is 5. 1, 2, 3, 4, 5. Yeah, 5. So here is going to be 5. 1, 2, 3, 4, 5-ish. 5-ish. So that gets flipped up, and so I've got this as my drawing. So that's my green drawing. So we did these. If you don't remember, you're going to have to look back. And we're trying to say, when does the yellow equal the green? So when does the yellow here equal the green? When are they the same? Well, they're the same right there, and they're the same right there. They're the same from, if you take a really close look, over here we have one, here's 0, 1, 2, 3. From 3 onwards, they're the same. And then from negative 3 onwards, they're the same. And that's what we got here. We have 3 and negative 3. And what does 0 equals 0 means? Well, that means that we have an infinite number of answers, which is incredibly strange. And so in class, we would talk about this a lot more. But the idea is we're going to have an infinite number of answers. We're going to have, where does this green graph and this yellow graph overlap? Well, they overlap from 3 to the right. So our answer is from 3 to infinity. And we can include 3, so it has a square bracket. And then we're also okay, it's from negative 3 left forever. So the other answer is from negative 3 to negative infinity. And so those are our answers, which are, I understand, is completely weird. And I don't know, I don't, you just need to do, there's some practice questions. I think I have some practice questions inside of the assignments. But the idea is you want to graph one, graph the left, and see where they overlap. Now again, how do you know when to do that? It actually is very easy to know when to do that. It's when you've got this weird statement, 0 equals 0, or 7 equals 7, or 12 equals 12. When you get this true statement where the x's have been completely eliminated, leaving you with something equals something, and it's a true statement. That's when you know the answer is infinity. And sometimes you'll get a drawing that looks like you'll get a drawing that looks like this. It'll bounce up like that. And then you'll get your other drawing to look like this. And so where do they overlap? Well, they'll overlap in the middle. So sometimes they overlap in the middle, and sometimes they overlap on the sides. Just depends on the question. So don't spend so much time on that. We'll practice that stuff in class. The biggest thing that you need to practice when looking at all of these questions, which are like absurd, is especially know how to do A. B would be good as well, but just B ends up getting you a decimal answer down here, which is hard to check, where A does not. But otherwise, A and B are virtually the same. C here is pre-AP. And keep all of this in mind, that is just the quadratics. There are easier ones. Like all of these, and to some extent, are a little bit more pre-AP. These are definitely the challenging ones. The other ones right here are linear, and so you definitely want to keep in mind example too, because these will take far less time. All right, so I'll just zoom in here a little bit in case you need to see something. Though I realize there is a lot going on here.